and welcome to the video. This is one video in a series of 4 which aims to show students exactly what a grade 9 question looks like in GCSE Maths. There is actually no such thing as a grade 9 topic, as some topics can be tested at grade 5, but then that same topic can also be tested at grade 9. It is actually based on how complex and how challenging a question is. That is what qualifies a question as a true grade 9 question. The simplest way to identify these questions is to look at the very last question in recent GCSE Maths papers. Here are some of those questions. This question is on the topic of coordinate geometry. You are given quite a bit of information, and you're probably going to need to start the question by drawing a sketch of the information you're given. The question has been allocated 5 marks. Could you pause the video at this point and have a go at answering this 5-mark question? Okay, welcome back to the video. Let's have a look at how I've approached this grade 9 question. So the first thing I've done is I've went ahead and used the information in the question to produce a sketch of what we're actually thinking about. I know A has the coordinates 4, 37, and I'm told that the line BC has the equation 3y equals 2x plus 12, and we need to find the line of symmetry. So if we're asked to find this highlighted line of symmetry, that's telling me that this must be a right angle. Because of the isosceles nature of the triangle, this line I've highlighted is actually the perpendicular bisector of BC. So the first thing I'm going to do is I'm going to work out the gradient of the line BC. So in order to find the gradient of BC, I need to put this in the order y equals mx plus c. It's already in the correct order, but I'm dealing with 3 y's instead of 1 y, which is why I've divided by 3. Once I divide everything by 3, I find that my gradient of BC is 2/3. Now I want to find the gradient of the highlighted line of symmetry here. We know it's perpendicular, so therefore it is the negative reciprocal of the gradient of BC. So I know the perpendicular gradient is -3/2. So now I have quite a bit of information. I have an x and y value, which is given to me from the coordinates of A, and I know A lands on that line of symmetry. And the gradient I now know as -3/2, and I found that from finding my negative reciprocal here. So with the information, an x value, a y value, and an m value, remembering that m stands for gradient, I can substitute those 3 values into the equation of a line. Y minus y1 equals m x minus x1. At this point, you may have used y equals mx plus c, substituted in your values and solved for c. But I'm going to use this version of the equation, and I'm going to substitute in the 3 values. So I've substituted in x1, y1, and m. Then I'm just going to go ahead and expand the bracket, which is why I've ended up with -3/2x plus 6, remembering that those 2 negatives there would give me a positive. And now I'm just going to manipulate the algebra to put it in the correct form. The question wants it in this form, where P, Q, and R are all integers, are all whole numbers. So at the minute, my x is on the incorrect side, so I'm going to add 3/2 to each side, and I'm also going to need to multiply through, so I'm dealing with integers because this is a fraction currently. So I've multiplied by 2 to get rid of the fraction. So every term gets multiplied by 2. And then I've went ahead and added 3x to each side. So it's equivalent of taking this minus 3x and moving it onto this side to become a plus 3x. I've added 3x to this side as well as adding it to this side. Now I have my answer in the correct order that the question asked for. If you leave your answer like this, when you're dealing with a fraction, you would not gain full marks because the question has specifically showed you to show a clear algebraic working and to give your answer in this form. And that's the question done. Very well done if you would have achieved all 5 marks on this grade 9 question. This next question has been allocated 6 marks and it involves the topics of volume of a cone, Pythagoras, as well as arc length of a sector. Could you pause the video at this point? Could you read the question carefully? And could you try and calculate the value of x and give your answer correct to the nearest whole number? So could you have a go at this grade 9 question now? Okay, welcome back to the video. So the first thing I'm going to do is I'm going to use my knowledge of the volume of a cone equation to try and work out the radius, to try and work out this radius here. So I went ahead and used this equation, a third pi r squared times h. This is given to you in the formula sheet, and that equals the volume of a cone. I'm told that the volume of a cone equals 1,600 centimeter cubed, which is why I've made it equal to this. I know the height is 25. That's also given to me in the question over here. So I'm going to solve for r. So I divide everything on this side by a third pi times 25, and then I take the square root to find that the value of r is 7.817 ... So I haven't rounded at this stage. But what I've worked out is this radius here, because I need to find some more information about the sector and about the cone in order to approach the question and find the value of x. The next thing I'm going to try and calculate is to find this arc length, the arc length here, which is quite difficult to visualize. But if you read the question, it does state that the sector can form a curved surface, which means this A is twisted around to touch B. If we visualize that, what that now means is this curved line produces the whole circular base here. So if I work out the circumference of this circle, the circumference of this circle will be exactly the same length as the arc A to B. And that's because this sector formed the cone when we joined it together. So I've just used my knowledge of circumference equaling pi times diameter, bearing in mind that diameter is twice the radius that we just found up here. And I then calculated that the circumference of this circle is 49.119 and so on. Again, I haven't rounded at this point, which also tells me that this arc length is the same, 49.119. So now I found a little bit more information that I can work with. Next bit of information I'm going to look for is this slant length here. So if we just look at this part of the cone, you can see there is a right angle triangle available. We know the height is 25, the question tells us that. This base here is the radius that we calculated up here. So we're looking at 7.817 and so on. From there, we are substituting in our values and using Pythagoras to find the slant length C. So I'm squaring 25, squaring 7.817, and then square rooting to find out the slant length here is 26.19. This slant length here that we're calculating here is also this line here. So it is the radius of this sector. So now I have a lot of information. I can now go ahead and work out the value of x. So if I use this equation here, that the angle I'm interested in out of 360 times pi times d, or pi times 2r, is going to give me the arc length. We now know that the radius is 26.19 given from here, and we know the arc length is 49.119 given from here. If we take these values and substitute them into this equation, and then we solve the equation for theta, or for angle x in this case, you can see I've manipulated the numbers around in order to find that x is 107.457 and so on. But the question asks me to give my answer correct to the nearest whole number. So I've rounded x to 107 degrees. And that is the final answer, which will allow me to achieve all 6 marks. There is, of course, other ways to approach this question in order to obtain your answer of 107 degrees, but whichever way you approach the question, this is the answer that you're looking for. 107 degrees will get you full marks. Thank you for watching, and remember, practicing past paper questions is easily the best way to be successful in GCSE Maths.